Alright, let's look at this epsilon delta proof of a limit. So we're trying to prove that the limit as x approaches 16 in the function 1 over x is 0.0625, which is 1/16 if you type it in on your calculator. So you can see that it is just 1/16, since that is continuous right there. So 0.0625. So that is the limit. That's going to be the limit. But we want to prove that it is using the epsilon delta definition. So notice this is 1 over x. That's our function. So I'm going to start right here with this part. So I'm going to say f of x minus L. So 1 over x is our function minus L 0.0625. And that absolute value is less than epsilon 0.0045. Alright, so that's the first part. Now remember, this absolute value means negate that 0.0045 is less than 1 over x minus the stuff that's in the bar, 0.0625, and that's less than the positive number, 0.0045. Okay, if you're smaller than this in absolute value, that means you're between that number and its opposite. So if I add this 0.0625 to everything, I'm going to get negative 0.0045 plus 0.0625 for the new left side. So 0.058 is less than 1 over x is less than, if I add 0.0045 and 0.0625 for the right side, I get 0.067. Okay, now, so think about this. Think about, let's do the xy plane. On the xy plane, think about the graph of y equals 1 over x, the function we're talking about here. Remember, that's got a vertical asymptote at the y-axis and a horizontal asymptote at the x-axis. And then it also does this stuff in quadrant 3. We don't really care about that because we're talking about these two particular values, which are positive y values. So that would be up here in quadrant 1. So just to kind of give you an idea, let's say, let me make that right in block 2. Alright, so there's one number, and there's the other one. This just for the sake of ease of sight and the idea we can zoom in as far as we want to on here. Let's say this one above is the y equals 0.067, and this is y equals 0.058. So these two horizontal lines. So this is where 1 over x is equal to 0.067. That's a little bit higher, and this is where it's equal to 0.058. Now what do we have to do as far as x goes? For the y value of 0.058, we have to move further out, right, in this function. To get from the y value where it's 0.067, the x coordinate that goes with that, like x1, x2. What do these x coordinates have to do? What's the property? The one that corresponds to 0.058 would have to be further out. And remember, 1 over x is just the reciprocal of x. So why is that so important? Well, because if I reciprocate 1 over x, and I reciprocate these two values that correspond to 1 over x, so if I take the reciprocal of 0.058, and negative 1 power, I get 17.241, that number. I'm going to click store alpha A. So that number became 17.241 roughly Alright, and then this 0.067, same thing. If I do 0.067 and reciprocate that, I'm going to hit store alpha b. So 14.925 roughly. Alright, now, well, what has to happen? Well, it has to be the case that when I take the reciprocal, and you can see it here, this number is now bigger than this number. And that's the way it would have to be, because the graph of 1 over x, as we make our way to the right, it always gets smaller. The y values always get smaller. So what does that mean? If we reciprocate it, what's happening to the x values? If we reciprocate this, we just get x. What's happening to the x values? Well, they're having to get bigger for these y values to get smaller. So if this was smaller before and this was bigger, it has to be the case that the x that corresponded to these values was the opposite way, meaning that this was a smaller x that produced that bigger y. This was a bigger x that produced that smaller y when we flip things around, because of the reciprocal nature of the function. Now you can also think of something that's probably easier to think through. It is like, you got 1/4, 1/5, 1/6. This is bigger than this, and that's bigger than that. Well, what happens when it's 4, 5, and 6? Well, now this is smaller than this, and this is smaller than this. So the point being, when you reciprocate numbers, when you reciprocate an inequality, the order changes. Alright, so we're getting these numbers. Alright, so now what am I going to do with those numbers? Well, I'm going to kind of rewrite it so it's a little easier on the eyes. So 14.925 is less than x is less than 17.241. And I'm not doing that because it's easier on the eyes. I'm doing it because this other inequality requires it. X minus c is less than delta. There's x minus c. C is 16. So the other inequality says, I'll switch to blue, says x minus 16 in absolute value is less than delta. Alright, just like before, we're going to get rid of the absolute values. We are going to negate that thing and put it over here just like we did before. And now we're going to add 16 to all three of these places. Okay, and I end up with 16 minus delta is less than x is less than 16 plus delta. And so I get the two equations. 16 minus delta equals this lower number, 14.925. And I get this upper equation, 16 plus delta equals 17.241. And then our job is to figure out which of these two deltas is smaller. Again, technically it's delta 1, delta 2. So delta 2 is 1.241, and then delta 1 is, take this from that, so delta 1 is 16 minus 14.925. .075. Oops. Right, and which one's smaller? This one's smaller. So that would be our value for delta.